Airborne Weather Radar. SHF 9.375 GHz, 3.2 centimetre wavelength. It's mandatory for all aircraft over 5,700 kilograms maximum certificated takeoff mass, or with a passenger seating capacity of 9 or more. Airborne weather radar detects reflected energy from water droplets or terrain. The reflected returns are displayed in plan form on a CRT, or may be superimposed on an EFIS navigational display. Airborne weather radar equipment cannot detect clear air turbulence, as this is seldom coincident with an accumulation of reflecting particles. The range is typically 375 kilometres or about 200 nautical miles. To prevent ground returns when using the radar for weather detection, it is necessary that the lowest part of the beam should be clear of any terrain. However, to allow for ground mapping navigation role, it is essential that the beam should be directed at the ground. To achieve these requirements, the pilot can tilt the plane of the aerial scan. For effective ground mapping, a cosecant squared beam is used to increase the view of the surface at short ranges of 50 to 60 nautical miles. Here's an indication of airborne weather radar returns on an EFIS screen and the Met reports of areas of severe precipitation over the Atlantic. ISO-echo circuitry. The ISO-echo facility of an airborne weather radar is used to detect areas of possible severe turbulence in cloud, and it basically draws a ring around areas of intense precipitation. Shadow areas. If the beam is tilted down and there's intervening terrain, a shadow area will be formed beyond the terrain. Airborne weather radar tilt. To calculate the height of the cloud tops above an aircraft, use the following formula. Cloud tops above aircraft in feet equals range in nautical miles multiplied by tilt minus 1.5 degrees multiplied by 100. For example, weather at range 40 nautical miles stops painting at plus 2 degrees tilt. The beam width is 3 degrees. The tops would be at 40 nautical miles multiplied by 0.5 multiplied by 100, which comes to 2,000 feet above your level. An aircraft is at flight level 290. The airborne weather radar is stabiliser on and in weather mode. Beam width is 4 degrees. A cloud top at 35 nautical mile range ceases to paint when the tilt control is 4 degrees up. The altitude of the cloud top is clouds in relation to aircraft equal tilt angle minus half beam width multiplied by range multiplied by 100. You are flying at 7,000 feet QNH. The tilt angle on the airborne weather radar at which an active cloud at a range of 40 nautical miles just disappears from the screen is plus 4 degrees. The beam width is 5 degrees. What altitude is the cloud top? Clouds in relation to aircraft equal tilt angle minus half beam width multiplied by range multiplied by 100. 6,000 plus your altitude of 7,000 is 13,000 feet.